So the first question is, Ohm's law may also be stated as J is equal to sigma E. What do the symbols J, sigma and E stand for? So that the combination of the units on the two sides are identical. So J in this case stands for your current density. Sigma stands for electrical conductivity, and E stands for electric field intensity or electric field. And the second part of this question is, so that the combination of units on the two sides are identical. So on our left hand side we have J, and on the right hand side we have sigma and E. Unit for J is current by the cross sectional area. So current has got a unit of ampere. Current has got a unit of ampere, and area is meter square. On the right hand side we have sigma. So unit of sigma is, sigma is 1 by resistivity. The unit of resistivity is into meter. So the unit for conductivity will be reciprocal of this ohm, that is this one, per ohm per meter, and E can be expressed as volt per meter. So if we multiply sigma and E, we get per ohm per meter into volt by meter. So this turns out to be volt by meter square and ohm, and V by ohm, volt by resistance, potential difference by resistance is current. So this has got a unit of current which is ampere and meter square. So on the right hand side we got ampere by meter square. On the left hand side also we have ampere per meter square. So the units, combination of units on two sides are identical. Okay, come to question number 4. In this is the circuit, we have to find current I1 and we have to find current I2. Here is a cell E1. Away from the positive terminal of the cell, I1 current flows. Here also we have I1 current, and here also we have I1 current till this junction. So in this part of the cell, towards the negative, I1 current flows. Here I1 current flows towards the negative, we have I1 current, and towards the negative we have I1 current. The next part of the circuit, having cell E2, away from the positive, this longer stick, I2 current flows. Towards the junction, I2 current flows. Towards the negative, I2 current flows. I2 current flows towards the negative. Now at this junction, we have to apply Kirchhoff's current law. We have I1 and I2, incoming current, sum of that will be I1 plus I2. Outgoing current, this is the outgoing current. Outgoing current will be the sum of the incoming current. So I1 plus I2 is what is flowing through this circuit. Through 2 ohm resistor, I1 plus I2 current flows. Then here I1 plus I2 current flows. Okay, towards this junction, I1 plus I2 current flows. Now at this junction we need to apply Kirchhoff's current law. Incoming current is I1 plus I2, outgoing current should also be I1 plus I2. Here we have I1 and here we have I2. So the current path is determined. Now we have to choose for the loop. So in order to choose for the loop, let me take first loop as this one. Here it begins from E1, okay, goes all the way and through I1 I2 and again all the way to E1. So this particular loop, let me call this as loop 1, and this is my loop 2. This full thing is my loop 2. Now let's go to the loop 1 first. Let me rub this. Now we need to apply Kirchhoff's voltage law in loop 1. So for that we need to first write the sign convention. Okay, we'll start from here. This is the I1 current, and we are taking this loop. So here we have plus and here we have minus, because the current is flowing from here to there. So we need to take this loop all the way here. Current is flowing in this particular direction, so this will be high potential, this will be negative. And 1 ohm is internal to the cell. Here we have 1 ohm resistor, and current is flowing in this particular direction, so this will be plus and this will be negative. Now apply KVL. Start from here, negative to positive. Minus to plus is plus. How much? E1, which is 25 volt. And here plus to minus current I1 plus I2 into resistance 2 ohm. And here we come plus to minus current is I1, resistor is 4, so 4 times I1, and internal resistance is there, so plus to minus current is I1, resistor is 1 ohm, 1 into I1. Equate that to 0, because we have come to the initial position. Equate that to 0. Now this will become 25 volt minus 2 times I1 plus, no, it's not plus, minus into plus, minus 2 times I2 minus 4 times I1. This is I1 minus I1 equal to 0. So we have 25 minus 2 I1, 4 I1, 6 I1, 7 I1, minus 7 times I1 minus 2 times I2, that is 0. So we keep unknowns on the one side. So I take minus I1 and minus 2 I1 on this side of the equation. So we have 7 I1 plus 2 I2 equal to 25. Or I can write this as 7 times I1 plus 2 times I2 equal to 25. So let this be equation 1. Okay, we have done for loop 1. Now let's do for loop 2. So for loop 2, we apply Kirchhoff's voltage law. This is my loop 2. So let's write the sign. This is minus to plus. Current plus minus we have written, and current is flowing in this direction, so this is plus and this is minus. We have internal resistance of 5 ohm here, so this is plus and this is minus, because the current is flowing from this plus side towards the negative. High potential is plus, low potential is minus. Okay, KVL. So start from here, minus to plus, value 26 volt. Here plus to minus I1 plus I2, I1 plus I2 into 2. Now we come here, plus to minus current flowing is I2 into resistance is 3 ohm. Then come to the internal one, plus to minus current is I2 and the resistance is 5 ohm, and equate that to 0 because we come to the initial position. Now this will be written as 26 minus 2 times I1 minus 2 times I2 minus 3 times I2 minus 5 times I2, equate that to 0 here. Now this becomes 26 minus 2I1, 3I1, 5I1. Oh, no, we have only 2I1. Okay, minus 2I2 minus 3I2 minus 5I2 minus 5I2 will be overall, it will be minus 10I2, and that will be 0. Okay, I take it on the other side. So while taking this on the other side, we have 2I1 minus 10 times I2. Oh no, this will be plus and equal to 26. Basically, I'm taking this and this on the other side, so sign changes. So I can cancel it by 2. 2 1 times, 2 5 times, and here we have 2 13 times. So this becomes I1 plus 5 times I2 equal to 13. Okay, this is equation 2. So we need to solve equation 1 and equation 2. So let me clear all those things except for 1 and 2. Okay, we come to equation 1 and 2. So we need to solve them. So let's multiply. See, this is, I want to remove I1. So here we have 7 times I1, and here I have only 1 time, only just I1. So I multiply this by 1 and I multiply this by 7. On doing so, this becomes 7 times I1. Let me do it here. So I have 7 times I1 plus 2 times I2 equal to 25. And here I have 7 times I1 on multiplying with 7 plus 35 times I2, 7 3 21, 7 1 7 8 9 91. So this is negative minus minus, this and this gets cancelled. This becomes minus 33 I2 2 times, and yeah, this is negative. So negative gets cancelled. So I2 we have 2 ampere. So we got I2. Now next we need to find I1. So let's substitute this in equation number 2. I2 I got as 2 ampere. So write this as 2 ampere. 5 2s are 10. I1 is there. Plus is there. And this is 13. Okay. The original. Substituting this in the original equation 2. So this is I1. And we have here 13 minus 10. 13 minus 10, 3. So I1 is 3 ampere, I2 is 2 ampere. So we got the value of I1 and I2. Okay, question number 5. We have a 100-watt bulb and 220 volt. So this is the power rating of the bulb. Okay, we have a bulb having power rating. This is connected to 110 volt DC power supply. So what is the power consumed in this case by the bulb? So this is the power rating of the bulb, which means when the bulb is connected to 220 volt, the power consumed is 100 watt. Now this bulb is not connected to 220, rather is connected to half of that, 110 volt. So what is the power consumed? Okay, we need to find the power consumed. So we know this relation, power is equal to V into I. So I have been given 110 volt. Okay, voltage is there, potential difference, but the current is not given. Okay, so we can express this current as V by R. Now the power expression becomes V square divided by R, power. I know V, but I don't know the resistance of this bulb. Right here, I don't know, but I can find the resistance from this relation. In this relation, I have been given power as 100 watt when the voltage is 220 volt. So resistance will be simple. So put this value of V and P in this relation. So this relation is P is equal to V square by R. So R goes up, R becomes V square by P. V square is in this case 220 square divided by power is 100. So this becomes 220 square is, we have 0 and 22 into 22 we have 224 8 and 4 divided by 100. 0 gets cancelled. So we got this 484 ohm as the resistance of this bulb. Okay, now I know the resistance of this bulb. So what is the power? Power is V square by R. When this bulb is connected to 110 volt, so voltage will be, this V will be 110 square divided by 484. Okay, so here we have 0 11 into 11 is 121 and 484. So this is divisible by 4. This relation, this I can write as 121 into 100. If you have calculator, you can straight away use your calculator. We have 484. So 41 42 41, this is 425 times, and this is 121. So we got power as 25 and the unit is watt. So in this case, when it is connected to 110 volt, the power consumed will be 25 watt. Go to question number 6. So question number 6 we have one point A. Yeah, whatever y axis. It goes to this EMF 1 volt. अर्को फेरि अर्को सेल जुन चाहिँको छ 2 volt. फेरि अर्कोसँग कनेक्ट भएको छ 5 volt. त्यहाँबाट यो ओह्रालो आएको छ. We have this. Okay. Let me drop this. त्यहाँबाट यो पट्टामा आएर 4 volt छ. फेरि यहाँनिर 4 volt छ. यो गएर B मा गएको छ. This is 4 volt and this is 4 volt. You have to find equivalent EMF between points A and B. So यो A भयो अनि यहाँ B भयो. यो डल्लै सेललाई मैले एउटा सिंगल सेल बनाए भने यसको भ्यालु कति हुन्छ त्यो खोज्नु छ. अब यहाँ हेर्नु, we have 1 volt, 2 volt, 5 volt. See, this has got a plus, negative. Negative is connected with plus of the other cell. Negative of that cell is connected to the plus. So negative plus यो कनेक्सनहरु सिरीज हो. So 1 volt, 2 volt, 5 volt series मा कनेक्ट भएको छ. So यिनीहरुको इक्विभ्यालेन्ट हुन्छ यो 5 plus 2 plus 1 जस्तै 8 volt. So यसलाई मैले रिप्लेस गरे यो टर्मले, यो ई सेलले. नाउ यसको एउटा एन्ड यहाँनिर गएको छ ए मा, अर्को एन्ड गएको छ बी मा. नाउ कम टु दिस 4 volt यो पनि नेगेटिभ पोजिटिभमा छ, सिरिजमा छ. सो यसको इक्विभ्यालेन्ट चाहिँ 4 र 4 8. सो 8 volt को अनि एउटा गएको छ यहाँ, अर्को गएको छ यहाँ. नाउ सी हियर, positive is connected here, negative is connected here. So positive एक ठाउँ कनेक्ट भएको छ, नेगेटिभ एक ठाउँ. So this is your parallel combination. यसको 8 volt, यसको 8 volt. So the EMF will be, यसको यो डल्लैको मैले इक्विभ्यालेन्ट त यसलाई मान्यो भने त A र B को बीचमा EMF हुन्छ 8 volt नै, किनभने parallel combination मा the voltage will be same. This is 8 volt between this 2 point. For this cell between this 2 point, voltage is 8 volt. Okay, now go to question number 7. Okay, question number 6 मा एउटा 60 watt, 1000 watt र 100 watt को बल्बहरुलाई सिरिजमा कनेक्ट गर्दाखेरि which will grow the highest, brightest. So जसले ज्यादा हिट प्रोड्युस गर्छ त्यो नै will grow the brightest. अब heat produce, we have this Joule's relation I square RT. Okay, heat produce depends on current flowing, resistance and time. Series मा कनेक्ट गर्दाखेरि सबैमा एउटै करेन्ट फ्लो हुन्छ, I current. Series मा करेन्ट सेम हुन्छ, सबैपट्टि I current नै फ्लो हुन्छ. अनि यसलाई मैले सर्टेन टाइम t को लागि छोडे पनि सबैलाई I will be leaving it for time t. So basically heat produce in this case depends on resistor. जसको ज्यादा resistance त्यसको नै ज्यादा heat produce, and that will go the brightest. Now we need to check for which has got highest resistance. So we know this relation, and the power दिएको छ, so power is V square by R. So V constant राख्यो भने power and R they are inversely related. भनेको जसको power सबभन्दा ज्यादा त्यसको resistance सबभन्दा कम्ती, जसको power सबभन्दा कम्ती त्यसको resistance सबभन्दा ज्यादा. Power कम्ती 60 वाट छ, so यसको ठुलो छ resistance, यसको अलिक सानो, यसको resistance is very small. So heat produced here will be more, and this bulb will glow the brightest. Okay, question number 8 ma question cha, name two conservation laws implied in Kirchhoff's law for electric circuit. Kirchhoff's को दुईटा law छ, एउटा छ KCL, अर्को छ KVL, Kirchhoff current law, Kirchhoff voltage law. So Kirchhoff current law ले कुन चाहिँ conservation law बताउँछ? At a junction, no? At a junction, incoming current, let's say it is I1, another is I2. Outgoing current will be I1 plus I2. So there is no buildup of charge at the buildup of current at the junction. Current is flow of charge, so there is no buildup of charge at the junction. Whatever how much ever charge is coming, that much ever is leaving. So this implies this law, conservation of charge. This law is satisfied, right? Implied by the Kirchhoff's first law, current law. Kirchhoff's voltage law ले conservation of energy imply गर्छ. So this was all for your test.